Okay, so we're going to take a look at some key features of functions here and what we want to know that kind of carries throughout most of the year here when we're looking at functions, particularly when we're looking at graphs. Okay, so here we have a function right here. Okay, we want to state the y-intercept of the function. So if I zoom in right over here and I take a look, where does it hit the y-axis? Right here. I'm going to mark that point right there. And I'm going to label that point 0, comma 2. So notice the x value is 0 for the y-intercept. That's a huge, huge, huge and important point, right? So if I write this as an ordered pair, it's 0, comma 2. So that would be the y-intercept of the function. The next one are the x-intercepts of the function. And what is the alternative name that we give x-intercepts? We can call them roots, and we can also call them zeros too. But the x-intercept of the function is also where the y value is equal to 0. So if I go ahead and look, we're looking at the x-axis. Where does it intersect? Right there. So that is the point 4, comma 0. You can see the y value 0. And this is negative 1, 2, 3, 4, 5, 6. That's the point negative 6, comma 0. So you want to get into a good habit of writing these as ordered pairs. It would be 4, comma 0, and then negative 6, comma 0. And you can see that the x-intercepts is where the y value is 0. Okay? Next question. Over the interval negative 1 to 2, is f of x increasing or decreasing? And notice that we're talking about the domain negative 1 to 2. So we're looking at this area. So from negative 1 to positive 2, is the graph increasing or decreasing? So the way we like to think about that is if we're traveling left to right, we can see that the graph is increasing, right? As x increases, y also increases. So one way to think about it, as x increases, y also increases, right? So that's a good, nice shortcut. You can tell that a function is increasing, right? Or you can kind of think about, hey, it's heading upwards, right? The graph is heading upwards. It's not really a good mathematical definition of it, but it's a good way to think about it, okay? Another value, and this is very, very important for SAT and ACT, you'll see this a lot, okay? Where is the function greater than 0? Or where is the function, I like to think about it positive, or where is the function above the x-axis, right? It's above the x-axis, okay? And what we want to look at here is if I go to the x-axis, we can see here that from negative 6, it's above the x-axis, and it stays above the x-axis. It goes up, it goes down, it goes up, it goes down, and then right there, it hits again. So you can say what interval is the function f of x greater than 0. You can say negative 6 is less than x, which is less than 4. Or you can say, using interval notation, you want to say negative 6 not inclusive up to 4 not inclusive. Because not inclusive because we want to know when it's greater than 0, not greater than or equal to 0. Okay? And then a last little thing we're talking about, state all the x coordinates of the relative minimums and then relative maximums. And what a relative minimum and a relative maximum is, since we don't know that this function is here, this point right here is a maximum. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. All right. So we can say negative 4, negative 6 is a relative maximum, right? Negative 4, positive 6, right? Negative 4, positive 6 is a relative maximum, right? Because it's a highest point, but it might not be necessarily the complete highest point, right? And then a relative minimum, right, is right there, right? It's going to go up, it's going to go down. Okay, so the point negative 1, comma 1 is a relative minimum. And what that means, it's not the complete lowest point, right? This right here and this right here are lower points, So we can say also that 1, 2, 3, 4, 5, 1, 2, that also 5 comma negative 2 is also a relative minimum. These last 2 points, like right here and then right here, those are absolutes. That's the highest possible value. And then this is the lowest possible value right here too. Okay? So the relative minimum and relative maximum are kind of like the bumps, right? They're the bumps that kind of go up and back down, and then they're relative. They're not like the absolute ones. Okay? All right, next one. Let's take a look at this. What happens if we have to graph this function? 2 absolute value x minus 1 over 8 over the domain negative 4 to 7. Okay, sketch a graph of the function on the right. So what I'm going to do here is I'm going to set up a graph. Okay, I'm going to set up a graph using my calculator. So I'm going to go into y equals, and then what I'm going to do is I'm going to say 2 times, remember, absolute value, math button, over to the number, absolute value, and then I'm going to do x minus 1, get out of the absolute value, and then I'm going to subtract 8, okay? So if I go ahead and look at the graph, that's what the graph's going to look like, okay? But if I want points in my table, all right, just go to your table and then choose some decent points here, all right? So negative 4, comma 2. So I'm just going to put this in right here and graph a couple of these points. I'm going to graph where it kind of bounces to. Hopefully you can kind of see that, all right? So negative 1, 2, 3, 4, 1, 2, I'll put a point right there. Negative 3, 0, I'll put a point right there. And you can see how this kind of goes down, and then it's going to bounce and come back up, okay? So negative 2, negative 2, right? Negative 1, and then negative 4. You can see how it's traveling just like a line. 0 comma negative 6, and then 1 comma negative 8. And then what happens here, it bounces. And this is what absolute value functions do here, right? At 2, it goes back up to negative 6, right? And you're going to see it's going to keep going back up and up and up and up. And we're going to stop right there because we're going from negative 4 to 7, right? The domain here runs from negative 4 to 1, 2, 3, 4, 5, 6, 7. All right, so there's the graph of this function, okay? This is a function, and it's not one-to-one, right? Because we have two outputs that are the same, okay? We have 2 places where negative 1 goes to negative 4, and then we have 3 also goes to negative 4. So it's not a one-to-one function, right? Over what domain interval is the function decreasing? So where is the function decreasing or going down here? And you can see here, if we want to look at this, are traveling down, we're traveling down, we're traveling down, all the way till we get here, okay? So what we say, where is the function decreasing? You can say it starts at negative 4, and then it goes all the way to positive 1, okay? Or you can also state this like this, negative 4 is less than x, which is less than 1, okay? Now state the zeros of the function. Where are the zeros of the function? Remember, the zeros are when y is equal to 0, or it hits the x-axis. Okay, and we can see this point right here and this point right here are where it hits the x-axis. So the zeros, we would say the point negative 3, comma 0. And then we'd say 1, 2, 3, 4, 5, comma 0 are the zeros. Okay? Last but not least is state the interval where g of x is less than 0. Okay, so now we're looking for where it is below the x-axis. And notice how this time we have less than or equal to 0. Okay, so we know that the zeros are negative 3 and 5, so we would say negative 3 is less than or equal to x, which is less than or equal to positive 5. Using interval notation, we would say negative 3, comma, positive 5, and then staple it off. Okay? Right? So you can see that there's a couple of things that we really want to make sure that we kind of have down here, right? Increasing functions travel up from left to right, or as x increases, y also increases. And then decreasing functions travel down from left to right. So that means as x is getting larger, y is getting smaller. Those are considered decreasing functions. Okay? Now to find the x-intercepts, we want y is equal to 0. So whenever you write an x-intercept, okay, the y value is always going to be equal to 0. And then you're going to have an x value, or a number here that represents the x-intercept. And then if you have a y-intercept, it's where x is equal to 0. So you would say 0, comma, whatever that y value is. And if a function is less than 0, or sometimes you can see less than or equal to 0, the function is negative, and we want to think about it as below the x-axis. Okay, so where is a function negative? If you wanted to do a little sketch like this, okay, you can see from here to there is where the function is below the axis. Okay, and then where f of x is greater than or equal to 0, if you wanted to create a sketch of that, and maybe look at a parabola like this, we can identify where is it above or equal to 0. You would choose this point, and from here to here, you can see the function is a positive function. Okay? All right, y'all. I hope this helps. Have a positive day.